All right, we are ready to start. Last time we almost finished up our CR Touch install, but we ran out of time working on the firmware. So we're going to pick up from there. Haven't touched it since, well, I guess I've touched the printer, but I haven't actually done anything on it since then. Actually, I did compile the firmware, but I'll show you what there was one little thing we had to do, but our actual problem last time was that I had mentioned that a lot of times when you're running VS Code, there's a lot of dependencies and updates and everything, and you just have to let it do all those updates, restart, let it find new updates and restart. Because I hadn't opened VS Code for, I don't know, several months anyway, and so it did have a lot of little updates. But we did have actual one error once we got through all the updates. So let's look at that. And pick up where that left off, compile some firmware, and get our printer back usable. We can turn it on now. We can do things like move the print head around. We can load filament and unload filament, but we can't actually print because we don't have a Z height sensor. I unplugged that, so it needs to know that the BO touch is there, or well, the CR touch, so that it can actually do something. So let's go over to our our firmware, which is still in Marlin, or well, it is Marlin. It is in VS Code. So you can see we got it to successfully build, but the problem, well, two problems. One was the one that I already mentioned about just having to let VS Code update because it was there were several. Like I think the platform IO had to update. I believe Auto Build Marlin might have had to update. Some of the stuff in the background. So there was a lot of updates. So I did that several times. And then it compiled, but not until I fixed this problem. So where's it at? Let's see. It does not tell me anymore. Maybe it doesn't tell me the actual problem. But the problem that I had was that there is in our configuration.h, we'll have to search for, actually it might be right here. Yeah, right here. So I did not enable Z safe homing, and this particular firmware, if you enable using the CR touch or BO touch or probe as the Z in stop, you have to enable Z safe homing also, or it will throw an error in the version of firmware. And I never enabled Z safe homing. So it did, once I fixed that and did all the updates in the background of VS Code, then it compiled. It actually compiled pretty quickly, so I'm hoping it compiled correctly. What you do is, or the easiest way to do it, is this Auto Build Marlin plugin. Let's see, it's off the top of your screen. Let me drop it down a little so you can see it. There we go. So this Auto Build Marlin plugin, or well, they're called extensions in VS Code. So extension does most of the building for you. So I would use it. I believe it's part of the instructions for the link that I had last time about installing VS Code to begin with. If it's not, it does make things a lot simpler. And then you click on build and wait. I think it was like 5-ish minutes. It had been a lot longer, but I don't think it took very long at all to compile this one. And then it will give you a file here. So let's see. It should go straight to the folder. I think there it goes. And actually I have two because I did another one this morning just to check that everything was running. And it'll give you firmware, the date and time. So the way these printers are supposed to work is if they see a bin file, so .bin of any kind, then if they do not recognize the name here, so it's not the current firmware name that they're running, that file name, then they will install it as firmware. So in order to make it so that it never gets the same name twice, they just put firmware, the date and time of when you compiled it, or when it was compiled. So that way it should be that anytime you put that firmware .bin, whatever the numbers are, onto a SD card, turn off your printer, put the SD card in the printer, turn on your printer, it should take that firmware and install it. Sometimes I've had trouble with that. Anytime I have trouble with it, what I do is I just give it a blank SD card and use firmware.bin as the file name, and it usually fixes it then. We'll try. I haven't actually uploaded it to find out, so we'll see what happens. I did want to show you one thing on these boot screens and status screen. The status screen's simpler. They give you little logos, right? So Ender 3 on the status screen, or on the boot screen it shows their dragon logo and I think Ender underneath it. That's all encoded in these bits. So I don't know if you can see on your screen I mean, if you look at it close enough you can tell, but all the ones are bits on the screen that would be turned on, and all the zeros are turned off. And so what this spells out is there is E, and then there's an N, there's a D, there's an E, R, a dash, and it normally says 3, but I did modify the pattern of ones and zeros over here, so it should give us Ender dash question mark. But you can edit these things to display custom images. If you don't want to edit them manually, these tell you, hey, you can just go to this website, put in a picture. Usually black and white pictures work better because it's not color, at least this screen's not color, so it's only on and off on the LCD screen. So a black and white image, a small one, I think it's like 60 by 60 pixels or something. It's a small image. This one's 8 by 39, but you can upload it and it will generate this code for you, and you can just drop it in. So like on the boot screen, you know, it's a larger image. It takes up the whole screen more or less, and this is what it would display. So can you tell that? I mean, I know what it is, so I can look at it, and you know, if you're far enough away and you kind of squint, defocus, then you can see there's the dragon and there's the word Ender. So you can put your own custom images on there if you want to. I'm just going to leave that alone. I did change this one to a question mark at the end because that was relatively easy to do just by hand. And then I compiled it. That was when I compiled the second time. So we're going to take this file. We need to get our SD card out of the printer. And we're going to transfer that file to our SD card and see if it will just work. It may. You can see I've already got, again, this is still the SD card that came with the printer, the one I told you not to use. I'm still using it, and so far it's actually been okay. There's hardly any files on it. These are just G-code, which those files are super small. Let's see what happens when we put our firmware on there. So I need to get the window, that one, and we will literally just drag it over there. And we'll copy it instead of erasing it from the other one. That's the more recent one. You can tell by the date. That was actually this morning. So now we'll eject our SD card. Okay, we will go over to our printer, put our SD card in. Now, what you want to happen is you want your LCD screen to basically be blue for 5 to 10 seconds. That if that happens, then without the little Ender logo showing up, that means that it found the firmware.bin file and it is flashing it to the board in our printer. So that's what we want to happen. If it immediately goes into boot mode, it didn't find that firmware file for whatever reason, and we'll try some other things. So let's see what happens. So it did turn blue. Alright, so it did not give us the logo. Alright, so now it did. So I think it probably flashed it. Oh, alright, so it did. So you can't see on here. But it says the EEPROM version, it doesn't know what, you know, it's new now. So remember, we lost all of our settings from our things that we saved. So we are going to initialize the EEPROM. EEPROM is electrically erasable, programmable, read-only memory. So it's not RAM, but it is ROM that you can go in and change the stuff. So that's where all of our settings, like our P, I, and D values and E steps and all that kind of stuff, we're going to reset that, and hopefully it is happy now. It says setting stored. Oh, and you can't see it, but right here where it normally says Ender 3, now it says Ender question mark, like we asked. Let me see if we can get a view of that or not. I don't know. You can kind of tell. It's kind of washed out on the screen. But now we should have, since we enabled BL Touch, we enabled a couple of things, we should have some new screens here. That looks the same. All of that looks the same. Actually, no, it doesn't, because it used to say TF Media here, and now it just says Media. Let's look in our configuration. There's probe Z offset, so it knows it has a probe now, so that's good. There's BL Touch, so it knows it has a BL Touch now. So I'm pretty sure that I'm confident now that the firmware updated. At first I was pretty sure when it just went to the blue screen, and then once it showed the question mark, then yes, it had updated. Alright, so what we do now is we need to make sure that our BL Touch is actually working. So it is lit up. Can I move it? Yeah. It is lit up. It will automatically go through a self-test whenever it's powered on, and it'll click, I think, twice, and then it should have a constant LED light. If it's flashing, that means it somehow failed its test. Usually what happens is the probe was too close to the bed and it didn't actually deploy correctly, and so it thinks it failed. That's not a big deal though. Alright, we're going to do an auto home. It should home X and then Y. Then it should go to the center, raise up and go to the center. That Z safe makes it raise up before it tries to do any homing. So let's see. Motion. I'm going to auto home, and let's be ready to shut it down. But alright, so there's the safe part. It raised up in case the probe was too close to the bed. These X and Y should work like normal, so they look fine. And it did go to the center. It raised up again. It deployed the probe. Actually, it's clicking the probe. I'm not sure about that part. So we have a little problem. It did not deploy the probe. I mean, it deployed the probe, but it didn't actually try to home anything. It just clicked it a couple of times and didn't do anything. So let's go back in our firmware and see if we can track down what might have been the issue there. So I do these things live so that you can see all the problems that might happen with this stuff when you forget something. So it did do the Z-safe homing, that's fine. And it went to home in the center of the bed, but it didn't actually ever try to home. So the sensor itself seems fine. It's not giving any errors as far as it's malfunctioning, but there might be something that we didn't enable here. So let's go back through our the beginning of the probe set, and maybe we didn't enable something. I don't know. All right, so we did enable the BL Touch, so that seems fine. Let's go up earlier. Let's go to the very beginning of our code. All right, so all of that's nothing there. That's the configuration version. All the green are just comments. They're usually good to read the comments, though, but right now we're not going to. There's the boot screen and the custom boot screen and the custom status screen, so that's fine. All of that seems fine. So there's some defines in here to make sure I don't leave anything out that I was supposed to there. Stepper driver should be fine. Single nozzle, we shouldn't have to worry with that. That's for a particular multi-filament type of extruder, but they only have one nozzle, so that's not what we're doing. These are all like multi-material type things. The thermal setting shouldn't be a problem. We did change out the hot end, but we didn't change any of the heater or the thermistor. These are all thermistors that we could have changed, but we didn't. And it's not giving us a temperature error, it just didn't home. We do need to do a PID tune, but we didn't actually change those. We overwrote the ones that we had previously. We did turn on the bed PID tuning. That shouldn't affect the homing sequence though. We didn't have a chamber that's heated. None of those. There's the thermal runaway that we made sure was enabled. Okay. In-stop settings. Alright. So let's make sure. Oh, alright. So this is saying use the Z-min plug, which we did not do. We unplugged it. So we might have to cancel that thing. We don't need any of those. These are all of our feed rates, E-step, that kind of stuff. We don't need to change those. It did move in the Z direction, so that's not a problem. Alright, so let's see. Enable this. Here's our probe. This probe replaces the Z-min in-stop and used for Z-homing. It doesn't tell us that we need to undo the other one though. Let's see. I wonder if we need it to be on -1. Define Z-min probe pin as -1. Let's do a quick search here on, what was that called? Z-min probe -1. So we're going to do Marlin I'm searching CR Touch Marlin Z min probe pin. This is the Marlin firmware, marlinfw.org documentation on this to see if there's something here. Let's see. That just tells about BL Touch. It doesn't actually tell about the way to set it up. I don't think that's what we need to do. Let's keep looking. We're not doing manual probe. Nozzle, no. There's that if statement. There's the BL Touch being enabled, which is also the CR Touch. It's not a solenoid probe. Not magnetically mounted. We're not using the duet board. We're not doing sensorless. So some boards, sensorless probing, some boards are able to measure the actual current drawn by a motor, and it sees that if one of the stepper motors is suddenly drawing extra current, that it probably ran up against a hard stop somewhere, like it hit the limit of whatever motion it could do, and it's detects that, oh, that must be the edge of the frame or whatever. But this board is not able to do that, so we're not doing sensorless. These are all of our offsets. Those shouldn't be a problem. We shouldn't need an activation switch. I didn't see anything there other than maybe the Z-min thing. Z homing height, that's fine. We may have to like do a little Google search on what we need to change here, because clearly we left something off. I'm just not 100% sure. Let's try to do, so it was trying to do homing. Actually, to do bed leveling, it has to do homing. I was going to say we can just try doing bed leveling, but we did do that. And it doesn't tell us any other functions we need to turn on. All right, so let's just search really quickly for Marlin and CR touch not moving down. So it did the, you know, self check. Didn't crash. It's not in high speed mode. None of those are actually anything. Oh, all right. So we. Oh, well. Z-min probe uses Z-min in-stop pin was commented out on that one. Let's see. I'm just checking to see if that's what the issue is here. PB1. Okay. I didn't actually see that one. I saw the negative one. Use probe. So let's check these. That is a 4.2.2 board, which is what we have. And that's what, yeah, that all of that's. All right, so let's see. Define probe manually. All right, so Control F to define, oh, well, probe manually. Most of these are, all right, there we go. There's 3 of these, so not that one. All right, so that's already commented out, so that's fine. Z-min probe uses Z-min in-stop pin, so maybe it does not use the in-stop pin. Oh wow, that was a lot. Let's see. Well, let's just do this. There we go. Cut and paste. So that one is enabled. Okay. Oh, you know what? I remember now. So some of these BL are actually not the CR touch that I've ever seen, but some of the BL touches, they had separate little pigtails on the cable where it was split, and some of them, like 2 of the wires, you would plug into the actual Z plug-in spot where your clicky switch is, and the other 3 you would plug into another spot. And so maybe we didn't do that. We put that all in one spot, so we're not using the in-stop pin location. So what else did they do? Let's check. We did that. I don't know if we did this part though. I didn't actually see that actually. Let's see. Yeah, that's not in here. There is the Z-min probe pin. Override this pin only if the probe cannot be connected to the default. Simplest option, blah, blah, blah. And that's where we did, it had -1. I don't like doing 2 things at once because then you don't know, you know, if it worked or not. Let's just do one thing. Let's do one thing, one change. You can see the build now. So we're gonna, we've made that one change. It automatically saves, but, or well, it will save. I'm gonna go through and save these just to make sure that nothing is not up to date. All right, actually, let's go to our little status screen and let's change up our symbols here so we can tell that something's different. Now we've got like a little exclamation mark or something. So let's save that. All right, auto build. We just click on this build, and it does not take terribly long to build. At least it hasn't the last 2 times I've built it. But we'll look at something else while it builds, because it's not instant. All right, so I do have a couple of things over here. One is this little guy. So see if we can get it to focus somewhere near him. So this is a FDM, not on this printer, but on a printer just like it from, I don't remember how long ago, but FDM print. So he does have layer lines if you look really closely, but you can get really high quality stuff off of just a regular 0.4 millimeter nozzle. I didn't reduce the nozzle. It wasn't a 0.6, but it was a 0.4 millimeter nozzle, probably 0.15 or so layer height. Pretty sure I can't measure that. And I printed it too long ago to remember it. But you can get pretty decent, quality out of FDM print. It does take a little bit of time. This probably took, I don't know, I'm going to guess 4 hours or so to print. I also printed him slightly at an angle, so he was sitting sort of back like this versus standing straight up. Mainly I did that. If you ever have objects like, something that has lots of detail and it has a clear front, so definitely this is the front, that's the back, then if you tilt the thing back a little bit, it'll add supports, but it will not add supports to the front part of your model. And so any of your little mess ups, like right here, I don't know if you can tell, but it's a little bit raggedy on the pants there. All of those will be on the back of the model. So that's a thing you can do if you know you're going to need supports anyway. Like if we printed him standing straight up, he's going to have supports somewhere. So if you just tilt him back a little bit, 40 degrees or somewhere in that range, you can tilt it a little bit and then slice to see where the supports end up at. Then you can at least control where the supports are. Now, Prusa Slicer, which we haven't used in class much or any at all, Prusa Slicer will let you paint exactly where you want the supports to be. There was a plugin in Cura that would do the same thing. It would let you paint on supports. I haven't seen the plugin currently, but it was in existence. I'm going to go ahead and turn the printer off because it's going to have to be off to update the firmware. But you have a little bit or a lot more control when you can literally paint with your mouse where you want the supports to be. I got the SD card out. All right, so we have built our new firmware. Let us go back over here to all of this stuff. So back in the background, it built us some new firmware. So now we have, same date, but 9:58 and 26 seconds. So like it's brand new. So if we click on that, actually I think it opened it for us. Yeah, there it is. And we're just going to put this over here. We do have this old firmware. It should not recognize this one because it's seen that file name, and the way the machines currently are operating, at least the ones like this Ender, is if it sees a file name it's already used, it won't use that file name. But I'm going to go ahead and delete that old one. Zero bytes. I guess it has already been used. So here is the new one, and we will eject and upload. We made our one change, and we'll see if that solves any of our issues. Okay, so we're back over here. I put the SD card in. Let's get it where you can see the screen, because that's what we're interested in. So it stayed blue. So it is uploading new firmware. There's our welcome screen. That's the boot screen rather. There's our new, now we have a exclamation mark. I know you can't tell it on the screen, but that's my little signal that yes, we did change our firmware. So let's try home and see what happens now. All right. So it's doing X and Y like normal. And then last time it went to the center like it should. It goes up, deploys the probe, and it's going down. Now I'm going to be on the, in case it doesn't actually trigger, we're going to shut it down. Oh, it did. All right. So that was our problem. I'll go back into the code and show you. Also, we got our offset pretty close to right. This probe is centering pretty much in the very center of the bed. Maybe not the exact center. Actually, I don't know. That looks pretty close to the exact center. I guess we could get our sheet of paper out again and, oh, I threw it away, so I don't have it anymore. The sheet of paper we used to mark the X to where the center is. So we should have a functioning printer again. All right, so we'll go back over here just to follow up on what we changed. So in configuration.h, we changed the, we did not change this one. So we left this one alone, and we changed the, where is it going to be? We might have to search for it again. We commented out this line. That one. So Z-min probe uses Z-min in-stop pin, which it does not do in this one. We used the cable coming from the CR Touch plugged into one socket on the board. It didn't split off some of the wires and send them to the existing Z trigger spot. In fact, we left those wires from the Z in there. And so that solved our problem. All right, so I think we're good with our firmware now. There are things you could play around with. There are some things that we should probably do. I'm going to go ahead and save everything, save that, close our firmware. There are some things that we should probably do, but we can save them. There are things like we need a PID tune. If we had changed our E-step setting, you know, calibrated that specific to what we had for our feeder, then we should change those. But I did order actually a set of hardened steel nozzles, so I don't really want to do a PID tune until I've got those on here. Let's do a test print. Oh, there is one thing we need to do. So let's close all these. Let's get Cura open. All right, so Cura, if we go into, and not just Cura, but any of our slicers, if we go into our printer, which one are we? I guess it's this one. That's the one that's labeled on. I guess that's the one we've been using. So I don't actually know. I should have named it something that I could find it. But that's the one we've been on. So let's assume we're on that one still. Let's manage printers and machine settings here. And I think, oh, we could have renamed it at that other screen too. But over here, we've got our start code. So let's just walk through what this code is doing. Actually, you might not can see that. Let's copy it and put it in something where we can actually see it larger. No. All right, so here's our start code, a little bit larger than it was before. So anything that's preceded by a semicolon is just a comment in this G code. This line, so the way the G code actually operates when it's telling your printer how to print is it will give it coordinates to move to, but it also tells it how much filament to extrude while it's moving. So if it's just a travel, then don't extrude any filament, or actually retract filament. But if you're printing some perimeter, then you need to extrude filament. And the way it keeps track of that by default is it will keep track of the total amount of filament that it is used in that print. And so it needs to start at 0. So this line here is telling it, no matter what you've done previously before this, reset all your filament measurings to 0. Now it doesn't actually measure the filament, it just keeps track of it in the code. This G28 is basically the same thing we just did on our printer when we did the auto home. That is what G28 is. It's not auto home, but it is home all axes. So it'll home X, then it'll home Y, then it'll home Z. You could, if you wanted to, just home one of them. You could just do, just tell it, just do X and don't do the other two. But we want it to home all of them. This line is one of the G1, so that's go at speed 1. And it is telling it to go to a certain coordinate. So basically, Z height of 2 millimeters. So 2 millimeters above the bed, because it just homed, so it's at 0. And then do that at a certain speed, 3,000, I think that's millimeters per minute, maybe. So pretty fast, but it just is a little 2 millimeter raise up. And then it's going to a start position. So this is, for me, it's doing that purge line on the left side of the bed. These lines here are making it do that purge line. You also see, they've got a E15. That means while you're going from, you were here, X equals 0.1, Y equals 20, Z equals 0.3. You were there. Go to this spot, X equals 0.1, so the same X coordinate, but 200 on the Y coordinate, so it's 180 millimeters. Same Z height at a little bit slower, actually a lot slower speed, but while you're doing that, extrude a total of 15 millimeters of filament. And then move over, and then go back. And this one is not saying extrude 30 millimeters, this one's saying get your extrusion count up to 30. You're at 15, so it's telling it to extrude another 15 millimeters of filament. Then it resets again because that amount of filament, that 30 millimeters of filament, isn't part of the print. That's just the purge line. So it resets the counter to 0 for counting filament. And then it goes to Z equals 2 millimeters. And then it moves over because there's probably a little bit of oozing that's happening under the nozzle. So it moves over a little bit and raises, actually it lowers it down to 0.3 from 2 millimeters. So what we don't have here is using our probe to mesh the bed to figure out is your bed tilted or not. So the easiest, simplest thing to do there is just go right under home all axes and do G29. So that'll be bed mesh. So whatever routine we told it to use in our firmware, which we did I think we did the linear and 3x3. I don't know if I ever showed you where the 3x3 part is. I think I did. But in that same configuration.h, you can change it from a 3x3 grid to a 4x4 or 5x5 or just 3 points, or different configurations. And so whatever we told it, and we didn't change anything, so it's going to be a 3x3 grid, meaning it's going to probe 9 different points on the board in a grid pattern on the print surface, and store that, calculate since we told it linear, it's just going to calculate the tilt of the bed, and then if our bed is tilted at all, it will adjust for it. So that's all it's going to do. So that G29 will do all of that before every print that we slice in Cura. So let's add that. Let's see, so we'll just add it right here. We don't have to put comments, but we can, as long as you precede them with a semicolon. And so that will cause it to probe the bed in 9 points. And then to save this, you just exit out of the window. And I'm pretty sure, yes, we could rename it here. Let's go ahead and rename it so that I don't lose it again. Let's say this is summer 2024. I don't know how long this name can be, so let's chop it down some. Enter 3. Okay, that way we can find it a little easier. All right. Now, there's a couple of other things that we need to do. One of them is on our printer, we have not set the Z height of our, the probe triggers before the nozzle is actually touching the bed, so there's some difference in there. We need to know what that difference is. I believe our little user manual, this little guy, gives us a routine for doing that, so let's see if we can follow it. Let's see. Prepare auto home, move all axis, so we did that. Move Z and stop the Z axis when the nozzle and the print head is about 0.1 millimeters. So they're going to set it where it's above the thickness of a sheet of paper. I like it to be at 0. So I'm going to do move axis. We've homed everything. We just did that. Everything's locked down. So actually, no, it's not. Let me home everything again. I thought it would hold all of the positions, but it didn't. Okay. Now, I want the Z, the nozzle itself, rather, in the center of the bed. So I'm going to move the X until it says it's... All right, so it's currently at 162. This is a 30 millimeter bed. Let's see. So it thinks it's at... It actually measures... Oh, because there's a perimeter here. It's not all the way at the edge of the bed that it can print. So I think we want it to go to 225 divided by 2, I think. Oh, can't do that, but 112. Although, I'm going to go there. That's close to the center. I was moving by tens, so it's not exactly on the center. And now I'm going to move the Z-axis by 1 millimeter increments right now. So it currently thinks it's, I think, 10 millimeters above the bed. Yes, it's currently thinking it's 10 millimeters above the bed. So I'm going to use my move axis on here to lower it down. I'm going to have to look to see when it's at the bed. So that's 10. Now it thinks it's at 0. And it is very close. There's about this ruler thickness that it's above. I'm going to switch my move to 0.1. Oh, it won't let me, it actually won't let me go below here because I've got the software limit set to where it won't let me go any lower than that. So it's about this thick. So I'm going to measure this. If you had a set, I actually do. Oh, could I find them quick enough? If you have a set of feeler gauges, you could actually use them to figure out the distance here. But I'm not sure I can find mine fast enough. I'm just going to use that it's about the thickness of this ruler, which is 0.8 millimeters. So the ruler doesn't slide under there very easily. I mean, it's more or less about 0.75 millimeters above the bed. It needs to go down minus 0.75. So that's our offset. And it said in our instructions, it said that we can, once we find our offset, we can input the Z-axis compensation value. So it says prepare, auto home, control, bed leveling, probe Z offset. So we got to find that. Said that was in prepare. I don't have a prepare. So I'm going to go to configuration. Probe Z offset. There we go. Now, I always get this backwards, whether I'm supposed to have a negative or a positive, but I think I'm going to give it a positive, as the offset is higher, like the probe is higher than the nozzle, but it might be the other way. So, oh, timed out. Configuration. So I'm going to give it a 0.75 positive, and then we'll auto home and go through the process again and see if we did it the right direction or not. Because it might be the other way. Some of the firmware actually have a routine where it will just measure the probe offset. You walk through the menu here. I didn't see that on this bit of firmware though. I didn't look for it that much, but I didn't see it either. So let's go back to where we were. Oh, I think I was there. Let's go to the Z move. And it thinks it's at 10 millimeters. Actually, let's go down by ones instead of... Alright, so I'm going to go down to 0 by ones. And we'll see if we're right on the bed or where we are. Alright, so it was the wrong way. It's higher above the bed than it was before. So let's go back to our configuration. Not a 0.75, but a minus 0.75. Alright, and then let's do the whole thing again. So some of this, you know, can be a little tedious going back and forth, but it's worth it to get your Z probe offset set, because once I get it all set and the printer firmware knows, you know, all of where the offsets are, then I can just switch out the bed surface with anything and it will automatically compensate for it, the thickness of it. All right, let's go. Motion, move axis, X. Get in the same spot we were in. Move Z by 1. All right, so and then I got to move by 0.1. All right, so it thinks it's at 0, and it is like right on the bed. All right, so it's right on 0. All right, so now let's try. Actually, let's save our setting. Where's that at? Main. I think that's probably in configuration. Store settings. Okay, so we should have that. I'm going to write it down in case it doesn't save it, but it seems like it did save it. So we use the probe offset of 0 or negative 0.75 millimeters. And we'll see how that goes. Now what I want to do is I want to make it do a bed level. So let's try that out. Assume that's in configuration BL touch. No, not there. Can I not do one from here? I don't see where I can have it do a there's a self-test, but I think that's just the okay, well, let's start a print that tells it to do that. And unless it's in motion. Oh, it is. For some reason it's in motion. All right, so Let's do level bed. Oh, that's probably going to do a manual level and then probably not a bed mesh. So that's the G28 home all. It is a good idea to have the bed as level as possible and not force the let me get these I might have to move this binder clip. Nope, it skipped it. Oh, so it's going to hit the binder clip there. And it might hit this one in the back. So this is it. I need to put them where it won't actually collide with them. This is it probing the bed in 9 spots. And I haven't had it do that yet, so I've got to make sure I don't have binder clips that are going to get crashed into. Oh, whoa, whoa. Alright, so that one didn't trigger for some reason. So, something about this corner is... I think it was the binder clip. I think that's what it was. Let's just put those binder clips on. We're about to get rid of the binder clips, but let me try that again. So that was actually a motion level bed. So I think the clip was just too tall and was actually hitting the chassis of our hot end, and it was just pushing the bed down, and the the probe tip from the CR Touch didn't actually make contact with anything, so it never triggered, and then it got below its safe, like it knew it should have triggered by that time, and it didn't. That one's alright, so that one's fine. And so it stopped. So let's see if it'll work this time. I'm wondering about this. That one might be a problem. Alright, so here's the one it failed on last time. Alright, so that time it was fine, but I don't have the clip in the way. So one problem with removing these clips on a non-magnetic bed is if this surface is, warped at all, and these were holding it flat, then it'll trigger at the wrong height. But I don't think this one is moving around when I put on the binder clips or not. Alright, so now what happens is that it has a mesh built into its brain, and if it noticed the bed was warped in any way, then it would account for that tilt. Now I did the linear, I didn't do the bilinear where it actually does a map of it. I just assumed my bed is flat and it's just tilting the bed in the software to match what the bed actually is in the real world. I might, let's see. I don't think I can actually see. I don't think I can see the coordinates that it captured to actually map the bed to see what it thinks it looks like. But now, as long as I have Cura with the G29, it's going to do that routine every time before it starts a print. Then you have to decide, well, it probably should do that when the bed is heated, because if I'm going to print on a heated bed, that heat is going to deform the bed in some way. And so I probably should have that. This bed is not heated. We were just trying to get it to work. So I probably should heat the bed first, then do the bed mapping. In case the bed is going to change shape any as it heats up to printing temperature. Actually, what we're going to do right now, though, is something we started to do a long time ago, if I can find it. And we're going to put our magnetic surface on here. So, why we didn't do that before is it was a different thickness, and we did not have a bed sensor. And we would have to go and adjust for different thicknesses every time we put a different bed on here. So now that we have a sensor that is calibrated, we've got their Z offset set correctly. Now we can put anything. We can put glass, we can put the PEI sheet, we can put whatever on here, and the sensor will detect the bed height and not have to worry with adjusting our limit switch over here. So let me grab our sheet. Here's the one we were going to use. So on one side, it's a lightly textured PEI, which is a good material to print most materials on. Some materials don't like PEI, or they like it too much rather, and they bond to it. But most materials are good with PEI. The other one is this, cool material. I forgot to look it up. I think it's PEU, but I'm not actually 100% on that. But it is a surface that it doesn't hold as tightly as PEI, but what it does do is it imparts this texture onto the bottom of your print, and your print actually picks it up. It doesn't pick up the color, but it picks up the texture of it. And they come in a variety of textures, like this triangle pattern, carbon fiber pattern. I'm not sure of other patterns. So what we need to do is clean this guy off. And I'm just going to use isopropyl alcohol. It should be relatively clean. I've never actually done anything to it, but just to make sure. Because the magnetic sheet is a stick-on sheet, so it's got a adhesive. This one has cutouts. Some printers actually have little alignment notches on them, particularly the Prusa, where you would need to have those lined up, but this printer doesn't have that, so they'll just be notches. So let's get our adhesive started. So kind of peel some of it back, get things lined up as best you can. If you're off a little bit, it's not the end of the world. You can cut this. This is just like, a refrigerator magnet thing. So you can cut it and trim it. The one thing I did do one pretty badly one time. And it would, as it moved back, it was off far enough that it would make contact back here. And all you do is you just trim off the excess. Like I'm a little bit off here, but I think we're good. So now we don't need the binder clips anymore, unless you're. So I'll make an exception to that. Unless you're printing something that is really large and it has like walls, like a big box. If you're printing a big box, the way that the cooling and the heated bed work on a lot of materials, and you're printing something in the shape of a box, is that those walls dump a lot of heat, into a box-shaped perimeter, and they want to, as they cool, they want to peel up. And if they're stuck down, you've got your PEI sheet on here, and they're really stuck down tight, then they can actually peel your sheet up. So if you're printing something like that, even with a magnetic bed, you may have to go and put your binder clips on there just to hold it down. I've only had that happen one time, but it's annoying because it's a long print and you don't think about that. Actually peeling the sheet up, the material sticks really well to the PEI, but the PEI is only so, or the magnet is only so strong. So you don't notice it until the print's pretty far in, and at that point you probably can't recover it, unless you noticed it right away and you get your binder clips on there. So now we can auto home, and since we've got a new surface on here, that this one's a little bit thinner than this one was, the sensor doesn't care. The sensor is just going to go down until it touches something, and it'll base all of its findings, its Z homing off of wherever it triggers the sensor. So now maybe you want to print on a sheet of glass. So they make glass surfaces you can print on, but you can also print on plain glass. And I've used like a picture frame from Walmart that has glass in it, the little $2 ones. You can take that picture frame glass, print on it, and glass works really well, as long as it's clean. So you do have to do a good job of keeping it clean, free of grease. But what you'll get is, just like the bottom side of this one has the triangle shapes on it, a glass will give you a glass-like finish on the bottom of your print. It'll be slick and shiny, so and it'll stick really well. Actually, some materials stick too well. I think PETG is one of the materials that will not release from glass if it gets bonded to it, and it's just, you need something like glue stick to be able to release the PETG from glass. So now we have those options. Now you can still, like, glass is obviously not magnetic, so you can still use your binder clips to hold the non-magnetic surfaces down. Let's see, what are we at? We got a few more minutes. Are there other things we can do quickly? We could do a PID tune, but there's nothing for you to see there. We're just going to do it on the screen here. I had written down that we were going to do TPU, and just not enough time to do any of that stuff. Let's start a print for a calibration of the bed, just to see how it's going. So I've got this guy loaded up. This is, I know that the parts for calibration extension doesn't show up in the marketplace for Cura anymore. So let's get it on the screen. There. It doesn't show up anymore. You can go to their GitHub page, and it's 5-axis is the person, or I don't think it's a company, but the organization that built that plugin. So you can still download the plugin and install it manually, but for some reason it's not showing up in the marketplace. Anyway, it has a lot of easy to use parts that you can just drop in. You don't have to go download them or anything. One of them is this. We printed this earlier, I think maybe the second day, the second day we had the printer running, as a way to check the bed level. So let's do that. We have updated our start G code to include the G29, which will do the auto home. If you want to do, you've got a big printer, so a large bed printer, then you might want to do you might not want to do the G29 every time. So you could do one mesh that's a really dense mesh for that large printer, and then store the mesh, and then just recall the mesh every time. So there are ways that you don't have to do the G29 before every print. You can just store it and then recall it when you want to use it. So this bed doesn't take long to do, so we're fine. Let's make sure that we're set up right. This is PLA 0.4 millimeter nozzle, layer height. Let's do 0.2. Let's do, we're probably in spiral vase mode. Let's turn that off. Yes, we don't need that. Let's do 2 walls, and it's only 1 layer thick, I think, so it doesn't matter how many layers we tell it to do. 205 is a good... Oh, actually, the PLA I've got in there right now is not 205. It is PLA, but it wanted to print hotter than that. I don't see its little card right now. Here it is. It wants to print at 220, so let's put 220. What about the bed? Bed at 50 is okay. All right, so we will cool, and we will have no skirt. And let's slice that. Preview it to make sure we're getting the right thing. Yes, that looks what we want. Save it to disk, which there it is. Let's call that bed level so we can find it. Eject our drive. Don't just take these drives, these little SD card drives out. They get corrupted pretty easily. Or at least in my experience they do. Alright, and now we'll go back to our printer and we will print from media, bed level, start. Okay, and we're going to print it on our PEI sheet. Now, one thing, this sheet and the other side of it, you can scratch those pretty easily. So you do want to make sure we're running a little bit of a risk on printing this without having printed anything else with our new sensor. I probably would be safer doing our first print on our plain old sheet that we've been using and then going over to our PEI. But I'm just going to watch it, and if it's scraping, then we will turn it off and go back into the drawing board on our Z height adjustment. I did, in our firmware, I did make sure that baby stepping was on. And so what that'll let me do is, as things are printing, I can double click this knob and adjust the height of our whole Z axis as it's printing live, so I can try to get a better offset. One thing I could probably get away with a larger offset on this sheet, because it does the PEI material. It will actually bond to the plastic, the FDM material, and hold it down really well, so I don't have to have as much squish as I would normally have on, like, maybe this sheet. So it's heating the bed. I didn't notice in our Cura that we had the bed temperatures. I think they've moved the bed temperatures outside of the start G code. It's just built into the G code. But we do want it to heat up the bed first, although it's taken a long time to heat the bed. That's kind of worrying me. It does have metal on it now versus it had a fiberglass type material before. So maybe that is good for heat distribution. The heater is underneath our bed, and it has to conduct through the magnet. Oh, yeah, that's it. We added the magnet. So the magnet is more like an insulator, and so it's going to give us a problem. That magnetic bed, at some point of temperature, not at 50, but at some point of temperature, we could demagnetize. We'll get to the Curie temperature for that magnet, and we could demagnetize it. So we'll have to look up and see what that limit is. I'm sure it's way above what we're going to be printing bed temperatures at, but it is taking significantly longer to heat our bed now that we've got that magnet on there. It's at 46 out of 50, so trying to get it to the 100 that we want to get to print. Oh yeah, I did get our this is the carbon fiber polycarbonate, so we've got a roll of that now. I bought it from Amazon, and so we've got our bed. It may take forever to heat, but the next step is get this thing running, get it all tuned up. So we need to do PID. We've got a couple of other minor upgrades, I think we'll add this guy. This is a metal version of the feeder. I don't really, and it's a dual drive side versus a single drive. We don't have time to do that today. Actually, we may not have time to get the print going. So we'll probably do this next time. And then I've got to decide. So in order to print the carbon fiber, it's definitely going to work better in a enclosure, which I have an enclosure. But the thing with the enclosure is you want to keep it closed to do the printing. So what I'd like to be able to do is heat the chamber using the bed, and then not have to open it up until the print is done. So that means I've got to have some kind of remote connection. And I think what we're going to do next is we're going to switch our firmware. I know we just changed our firmware, but we're going to switch our firmware over to one called Clipper so that I can remotely log into it. It's going to change the way it operates significantly too, but I can remotely log into the printer and monitor it if I have a camera. Actually, I do have a little camera right here that we'll use. So I can remotely log into it, remotely monitor it. It can stay in its little enclosure, keep the chamber nice and warm, and print, hopefully, our polycarbonate. In order to do Clipper, though, I'm going to need, where'd it go? I'm going to need a Raspberry Pi. So I bought a cheapie, well, cheap for today's, it used to be a lot cheaper, Pi 3B Plus. So that's about the lowest one I like using for the Clipper install. You can probably get away with a little bit less power one, and there's a Pi 5 now, so there's certainly more powerful ones, but 3B Plus is fine for what we're going to do, and probably even a little bit weaker ones will be fine too. But if you don't know, a Raspberry Pi is a single board computer, not just like a microcontroller, a full-blown computer. You can run an operating system, monitors, keyboards, mouse, all that kind of stuff off of it. But it's going to take over the job of our motherboard that's down in here. So it's going to take that job over, and it's going to also take over and let us do wireless communication. Either we'll use Wi-Fi, so that we can remotely log into the thing. So I think that's what, our next step is going to be this guy, and then this won't take too long, and we'll start installing our Raspberry Pi and Clipper so that we can remotely log into this. So we may not have too many appearances of the printer because it's going to be off somewhere else doing its little thing, polycarbonate, and we'll just look at it remotely and monitor it from there. And this camera is a Pi cam, so it will interface directly with the Raspberry Pi. You could use a USB webcam, fine. I just have that, and it's more compact than a webcam. We are almost at 50. I am not sure. I've never seen it take this much longer to heat the bed just by adding the magnetic strip. So we may have to reconsider some of that to get it up to the printing temperature for the polycarbonate, because we want the bed at like 100 for that. So if we're taking this long to get to 50, we may have to think about how are we going to get to 100. Now, it being in a chamber will help, but you don't have to use the magnet with these. You can just binder clip it down. So maybe we'll take the magnet off of there and see if we can speed up some of this bed heating. All right, so it's about the end of class time, 10:45. We did not get our print started. I'll go ahead and let it finish so that I can check the results of how good our bed mesh is doing. But it's taken forever to get up to the bed temperature. Actually, it just gave up. It got at 49 out of 50 and said that's good enough. I'm going to heat the extruder. So it's going to heat the extruder now. I'll stay on just because once now it's doing that, it shouldn't take too long to do the print. But I will see y'all on Wednesday with the all metal. Well, I shouldn't say all metal because this is not a hot end. This is the feeder mechanism back here. And I'm just going to change it because the one that's on the printer is plastic and a single-sided one, and this one's metal and a double-sided one. So we'll see that on Wednesday, and that should still give us time to do our Raspberry Pi. Maybe even get Clipper completely installed. Clipper is actually pretty easy to install these days compared to what it used to be. So we should have a remotely operated printer by the end of Wednesday, certainly by Friday. It's getting the extruder up. Oh, the extruder also has to go hotter than it was before because we wanted to print this material at 220. But it's already at 203, so it shouldn't take too much longer for it to get up to speed. Then it should do an auto home and capture a mesh, and then start printing. Hopefully. All right. It actually overshot. So the PID tune on this is all wrong because it just went back to the default settings. So it way overshot. It went to 224, so it's actually cooling down now. It got the bed to 50. So we may have some issues just on maintaining a nozzle temperature. But it's happy now to go do its home. Okay. Still doing the Z fine. We don't have any binder clips in the way on our mesh beds level, so it should do that next. I don't see a purge line on our preview. I'm not sure why it didn't do a purge line. Maybe it just didn't preview it. See, you can imagine if you were doing a larger grid with more points, this part of it could take a while on a large bed, and so you might want to have a pre-stored mesh that you just recall the mesh. This one's only a 3x3, and I'm only using linear mesh compensation, so I could get by with just 3 points if I wanted to. Alright, so that's the last of the points. I think it'll come to a purge. I don't know. Nope, it's going to... so this is one thing I don't like about the CR touches. I'm just checking the... Alright, so we do have extrusion and it's not scraping the bed. Now, this line is printed at a 0.3, Z of 0.3, so I'm interested that... This is what I want to know. It's not scraping anywhere. So that looks good. All right, so we'll let it go and do this, and then we'll analyze it. What I don't like on this CR Touch is I've had a lot of them. I don't know how many. Let's say 5. And at fast travel speeds, they rattle. So the little probe in there is just loose enough that if you're moving at a faster speed with the non-silent drivers at least, so the noisy ones like mine, that the probe rattles. I don't know if you can hear it, but occasionally I hear it rattling, and that can be annoying. Now we're going to put this in a box in another room, so it won't bother us. But that is something I've noticed on these CR Touches. Then the BL Touches don't. I've never noticed them rattle. So it's doing all the little grid. You can barely see it on there. I'm more interested. These are printing well. I mean, they look fine. I'm more interested in the squares, though. I just suppose it's going to do those last. So on the bed mesh, if it detected this was not level and it was tilted some way, then as it's moving through the first couple of layers, it doesn't do it through the whole print, but there's a fade out of when, like after 3 layers or 4 layers or something, it doesn't do it anymore. But your Z, I'm trying to feel the Z axis back here and tell if it's activated while it's printing, and I don't feel it moving at all. So either our mesh is perfectly flat or close enough to flat that it's not, you know, it's not really having to travel up and down a incline, or it's not working. I'm gonna say that this is pretty flat. Oh no, I felt one little step. So it's kind of like it's going uphill here. But it was one step, not a significant amount. So it is adjusting for the flatness or the levelness of the bed. Level, again, level, when I use the word level in 3D printing, I mean level with the machine's motion system, not with the ground or with earth or anything. You know, based on this, I'm going to say that we've got our Z offset tuned pretty well. We've got, this is some really old filament. It's a sparkly, I think. What's it called? This is an old PLA tritium green from Fusion Filaments. I don't even know if they're still a thing or not. This is an old bag I found. It's like, oh, that looks interesting. But it says it's a translucent green PLA with some sparkle. So we'll see. I'll print one of the, assuming that it will print fine, I'll print one of our vases to see what it looks like. I probably should not have done 2 walls on this. That's why it's taken so long to do all of these outer perimeters. 1 wall would have been fine. It's not like it needs any strength. So on your slicer over here, and you're doing this print, probably going to save you a lot of time just to do 1 wall instead of having to trace around everything twice. So now what we want is we want to check each of these squares, and I want to have the lines of the square. So once this moves out of the way, you'll be able to see some. I want to have the lines of the square all touching, and that one looks pretty much perfect, actually. I want all the lines touching. I don't want gaps between the lines. That means that the nozzle is too high. You know, it's not squishing the layers out or the lines out enough. And I don't want them translucent. If they're like, well, this is a translucent filament, so I probably shouldn't use that. But if they're see-through, that means that the nozzle is too close to the bed and it is squishing them too much. The other thing you'll see is somewhere in between where maybe it's not like squished so much that it's see-through, but there are these little waves and ripples on top of the surface. That's also nozzle too close to the bed. This one is pretty much perfect here. That other one looks pretty perfect too. So if you're having trouble with you know, adhesion or first layer issues, it could be that your bed mesh, if you're using a probe, your bed mesh is not correctly set up. Maybe you recorded it when it was a cold bed and then you print on a hot bed and don't redo the calibration. Maybe you don't even have one of these sensors. If you don't have one of these sensors and you don't want to buy one, they're like $30 or whatever, and you don't want to go through the trouble of installing one, you can do that same process manually. So if I still have, oh, I closed it. Well, I had the VS Code up. In the VS Code where you're doing the configuration.h, there is a option to do a manual mesh. So same kind of procedure that we did. You have to go into the firmware, recompile and everything, but turn on manual mesh. You'll get a new menu in your display to do the probing manually. But what it'll do is it'll move the probe to the spot, and you'll have to go and adjust up and down until the nozzle's right on the bed. And you click the button, it moves to the next spot, and so it manually detects how far you had to move the nozzle up or down, and it stores those coordinates just like it would do with the probe here. So you can get a mesh done manually. You definitely don't want to do that before every print, but you do it once and store it and let it use that recall that stored mesh, which I think I have to look up the command for that. Marlin recall stored bed mesh. Let's see what the command is. That there it is. Oh, you're not looking at that. So it's M420S1. So assuming you've stored a mesh on your printer, then you can use this command and it'll store it. Or actually, G29S0 gets it, so it loads it, and then M420S1 uses it. So you can store a mesh and then use it. That's all same process if you have a really large printer and it just takes a long time to probe, even with the sensor, then you can do it once and then recall it and use it. These are looking great. I don't see any problems with these. It still hasn't done the back three, but those look great. I'm assuming sometimes that corner back there is, or that one, is a little bit tough to do because it's a different setup. That's where the strain relief is on the bed, and sometimes it's just different. Although the little square looks fine. I'm going to say that these are great and probably shut it down. Although it's 70, I'll let it finish. It's 78% done. I just have to get ready for the next class, so I can't wait too much longer. Well, speaking of that, it reminds me, so maybe you've got just a little bit of print left and it's fine,